What is power quality anyway? Big buzzwords in the industry. We can find definitions in IEEE standards, NFPA standards, Electrical Engineering Handbook, various textbooks. But what power quality means to us folks out in the field? We'll have to go out and try and figure out why the circuit breaker tripped when there wasn't too much current flow in the system, or why the lights are flickering, or why a motor burns up when we just took a clamp on ammeter reading and it doesn't show that there was too much current flow going to the motor. The chiller maybe suddenly has some control problems and we're getting high temperature alarms in the server room. Computers crash, lock up. We've got to go out and solve these problems. Inadvertent alarms and trips on PLCs and variable speed drives. Well, those could all be power quality problems. But here's the practical side of it. Power quality is the study of the voltage and the current sine waves that we apply to our equipment, and that certainly apply to our premises distribution wiring system in our buildings as well. Now, if the equipment operates properly and the premises wiring system functions properly, we might say, oh, we've got good power quality. But if the equipment runs into some of those problems we were just talking about, or if we have problems in the wiring system, such as neutrals overheating or transformers burning up, then we might say, oh, we have poor power quality. And when we talk about power quality and studying these sine waves, what are we really talking about on the sine waves? Well, what we want to know is, are our sine waves nice and smooth and clean? Do we have good clean power we're applying in our distribution system into our equipment? Or do we have some notches maybe along the sine wave? Or is it distorted in any way, jagged? Is it flat across the top? Those could be problems that could cause misoperation of our equipment. Do we have any unwanted currents flowing in our system at frequencies other than 60 Hertz? Those we call harmonics. Harmonics can cause the neutrals to overheat, burn up transformers, burn up motors, distort our voltage sine wave, and cause us other problems as well. Are my voltages balanced from phase to phase? If not, I can destroy motors. Are the magnitude of my voltages, are they too high or are they too low? Lots of times if they're too low, I can end up burning up equipment. So in other words, do I have what we call swells and sags on our voltage levels? Well, here's the rub. A lot of those problems that we're talking about that we have to go out and find, we can't locate them with the digital multimeter. Even a good quality digital multimeter, the best quality we can buy, can't find a lot of those problems like harmonics and transient conditions on our voltage sine wave and so forth. So how are we going to locate those? We've got to go one step further. We need something called a power quality analyzer. Don't worry, here's the good news. It's not rocket science.